On a humid morning in August 1943, Sergeant James McKenna stood beneath a fighter plane at a dusty airfield in New Guinea, knowing he'd just committed a court-martial offense. The young pilot climbing into the cockpit had no idea his aircraft was different from every other P-38 Lightning in the Pacific. What McKenna had done the night before, working alone in the darkness with nothing but a pair of pliers and a scrap of wire, would ultimately alter the course of aerial warfare in ways no one could have predicted. The P-38 Lightning was supposed to be America's answer to Japanese air superiority. Twin engines, twin booms, sleek and powerful, it looked like something from the future. On paper, it dominated. In reality, American pilots were dying at an alarming rate. The Japanese Zero, lighter and more nimble, could execute turns that left the P-38 struggling to keep up. Every morning briefing hammered home the same message: never try to turn with a Zero. Use your speed, use your altitude, dive in fast, take your shot, and get out. Simple doctrine, except combat was never simple. McKenna had been maintaining these aircraft for 8 months. He knew every bolt, every panel, every system. He'd watched dozens of pilots taxi out for missions. Some returned, some didn't. The ones who came back always mentioned the same thing. The controls felt sluggish during hard maneuvers, like the plane was fighting them. The training officers blamed pilot error. The pilots blamed bad luck. But McKenna knew something else was wrong. Lieutenant David Chen was the first pilot McKenna personally lost. Young guy from Sacramento. Loved talking about the cars he used to fix back home. Chen flew a mission in early July and barely made it back, his plane riddled with bullet holes. He told McKenna the aircraft felt like it was responding half a second too late. Just enough delay for the Zero to line up a perfect shot. Only his wingman's intervention saved his life. 3 weeks later, flying a different P-38, Chen died over Rabaul. The official report cited pilot error during defensive maneuvering. Then came Captain William Morrison, an experienced flight leader with 11 confirmed kills. Morrison knew the Lightning's capabilities and limitations better than almost anyone. In early August, his flight engaged 8 Zeros over Oro Bay. Morrison shot one down on his first pass, but 2 more reversed on him. Over the radio, his wingman heard Morrison say his controls felt mushy, unresponsive. The Zeros stayed with him through every evasion attempt and shot him down at 4,000 feet. The crash killed him instantly. Morrison's crew chief, a Texan named Rodriguez, became obsessed with finding out what went wrong. He examined every inch of the recovered wreckage: engine settings, control rigging, cable tensions, everything checked out perfectly within specifications. The aircraft had no mechanical faults, yet Morrison, one of their best pilots, was dead. Rodriguez didn't accept the pilot error conclusion. Neither did McKenna. By mid-August, 17 pilots had died. McKenna had signed off on maintenance for every single aircraft they flew. He'd watched them take off, disappearing into the tropical sky toward enemy territory. The losses haunted him, not just because they were tragic, but because he understood what was killing them. The P-38's aileron control cables ran through the twin booms, connecting to the wing surfaces through a series of pulleys. Factory specifications allowed for a tiny amount of slack in these cables, maybe 3/8 of an inch. Engineers considered this acceptable. But McKenna could feel that slack when he worked on the system, and he understood what it meant in combat. That fraction of a second delay between when a pilot moved the stick and when the ailerons actually responded was the difference between life and death. At high speeds during diving attacks, it didn't matter much, but in low-speed turning fights, when split-second reactions determined who got the shot and who got shot, that tiny delay was fatal. Japanese Zero pilots had learned to exploit it. They'd bait American pilots into turns, knowing the P-38 would respond just slowly enough for them to get inside the turn, radius, and line up a killing shot. McKenna had mentioned this problem to the engineering officer 2 months earlier. The officer's response was predictable. Cable tension was within factory specifications. Changing it would void the warranty, and field mechanics lacked authorization to modify flight control systems. Any changes required approval from Lockheed's engineering department in California, 7,000 miles away. The bureaucracy was designed for safety, but it was getting pilots killed. Lieutenant Robert Hayes was 23 years old, a farm kid from Iowa who'd been flying combat missions for 2 months. 6 missions, 0 kills. Not because he lacked skill, but because he followed the rules exactly as taught. The doctrine kept putting him in positions where he couldn't capitalize on opportunities. He'd dive on enemy fighters with perfect positioning, only to watch them slip away while his aircraft slowly responded to his commands. On his 5th mission, Hayes watched his wingman die. Lieutenant Thomas Parker, his friend from training, got caught in a turning fight with 2 zeros. Hayes heard Parker's voice over the radio, heard the panic as Parker realized his plane wasn't responding fast enough, heard the gunfire, heard Parker scream, then silence. The evening of August 16th, Hayes came to find McKenna in the maintenance area. The young pilot's desperation was obvious. He asked if there was anything at all, that could make his aircraft roll faster. He didn't care about regulations or proper procedures. He just wanted a fighting chance to survive his next mission. McKenna looked at this frightened kid and made a decision that could have ended his career. That night, working alone after the rest of the crew had gone to sleep, McKenna opened the inspection panel on Hayes's P-38. The cable's slack was exactly what he expected. He'd salvaged a 6-inch piece of piano wire from a wrecked aircraft 2 weeks earlier, not knowing then why he'd kept it. Now he understood. He bent the wire into a Z-shape with pliers, a process that took 8 frustrating minutes and left his thumb bleeding. The wire fought back against every adjustment, but eventually he got the shape right. Installing it was harder. The space inside the boom was cramped. McKenna had to work with one hand while holding a flashlight with the other, shadows jumping across the cable system as his hand trembled. He wedged his shoulder against the boom structure, feeling the metal edge cut into his arm. Sweat dripped down his back despite the cool night air. He disconnected the cable at the pulley junction, fumbling with the clevis pin until he dropped it. 5 minutes of searching in the darkness before he found it again. Every moment increased his risk. If anyone caught him making unauthorized modifications to a flight control system, he'd face court-martial, possibly prison time. But Hayes was going to die without this change. McKenna inserted the piano wire tensioner between the cable end and the pulley, reconnected everything. The fit was tight, requiring him to force the clevis pin through. When it finally seated, he tested the cable by hand. No slack. The control surface moved immediately with 0 delay. Perfect. He replaced the inspection panel, cleaned his tools, wiped the blood off everything, and walked out of the hangar at 1:15 in the morning. The modification had taken 8 minutes and added less than half a pound of tension. It eliminated the slack completely. McKenna didn't sleep that night. He lay in his bunk watching the ceiling, thinking about what he'd done. He'd violated at least a dozen regulations, used a non-standard part, modified a critical flight system without authorization. If the modification failed during flight, Hayes would crash and McKenna would be directly responsible. But if it worked, Hayes might survive. At 6:30 in the morning, McKenna walked to the flight line and watched the ground crew fuel and arm Hayes's aircraft. He watched Hayes receive his briefing and climb into the cockpit. At 7:42, the P-38 rolled down the runway and climbed into the morning sky, joining formation with 16 other aircraft heading northwest toward Japanese-controlled airspace. All McKenna could do was wait. The engagement began at 8:14. Hayes's 4-ship flight intercepted 9 zeros at 13,000 feet over the Huon Gulf. The morning sun was behind them, perfect setup for a diving attack. Hayes was flying number 3 position. His element leader called out the attack, and they rolled in. Hayes picked a 0 at the back of the formation and dove, building speed to 380 miles per hour. The enemy aircraft grew larger in his gun sight. He could see the painted rising sun on the fuselage, could see the pilot's head in the canopy. Hayes pressed the trigger and his guns hammered, tracers reaching out. Most missed, but a few hits sparked off the Zero's wing. The Zero snap rolled right and dove. Hayes rolled to follow, And that's when everything changed. The airplane responded instantly. No delay, no lag, no fighting the controls. The stick moved and the aircraft rolled immediately, like it had been waiting for his command. Hayes had never felt his P-38 move like this. He rolled 90 degrees in what felt like half the normal time and got his nose down, though the zero was right there in his sight picture. He fired again, a 3-second burst. The rounds walked up the Zero's fuselage from tail to cockpit. The engine exploded, pieces flying off as the aircraft rolled inverted and fell toward the jungle below, trailing black smoke. Hayes's first kill, but no time to celebrate. His wingman called out Zeros diving from above. Hayes looked up and saw 3 of them coming down fast. They'd watched him shoot down their comrade and wanted revenge. Hayes shoved the throttles forward and started to climb, but the Zeros were faster in the dive. They'd be on him in seconds. His only option was to reverse and fight. Every instinct screamed to keep climbing, keep running. That was the doctrine, but doctrine meant dying today. He rolled hard left and pulled. The P-38 snapped around like nothing he'd ever experienced. The nose came through the horizon and he saw the lead Zero. It was turning to follow but hadn't expected Hayes to reverse that quickly. The Zero was exposed, vulnerable. Hayes pulled lead, fired, and hit the Zero in the left wing root. The wing folded and the aircraft tumbled out of control. 2 kills in 30 seconds. The other 2 Zeros tried to scissor with him, alternating turns to force and overshoot. Hayes stayed with them. Every time they reversed direction, his P-38 snapped into the turn instantly. No delay, no fighting the controls. The airplane did exactly what he wanted the moment he wanted it. It was like flying a completely different aircraft, like someone had removed invisible weights from the control system. One Zero made a mistake, reversed too hard, and bled. Too much speed. Hayes got inside his turn at close range, maybe 200 feet. He fired and couldn't miss. The Zero came apart, pieces of aircraft falling past Hayes's canopy. He felt his P-38 shudder as debris struck his right boom. 3 kills. The 4th Zero ran. Hayes didn't chase. He was low on fuel and ammunition. He climbed back to altitude, reformed with what remained of his flight, and headed home. The entire engagement lasted 7 minutes. When Hayes landed at WWII at 9:03, McKenna was waiting on the flight line. Hayes shut down the engines and climbed out of the cockpit. His hands were shaking, his flight suit soaked with sweat. He walked straight to McKenna and said 2 words. It worked. What neither of them realized was that 6 other pilots had watched Hayes's engagement from altitude. Captain Frank Mitchell, a flight leader in the 475th Fighter Group, saw the entire fight from 15,000 feet. He'd been watching Hayes's element engage the Zeros below when he noticed something unusual. Hayes's P-38 was rolling faster than any Lightning Mitchell had ever seen. The aircraft snapped through maneuvers like it weighed half what it should. Mitchell knew every pilot in theater and their skill levels. Hayes was good, but not that good. Something was different about his airplane. After landing, Mitchell found Hayes in the debriefing room, still running on adrenaline as he filled out the combat report documenting 3 confirmed kills. Mitchell asked what was different. Hayes said he didn't know. His airplane just responded better today. Mitchell asked if maintenance had done anything to the aircraft. Hayes told him to talk to Technical Sergeant McKenna. Mitchell found McKenna in the maintenance area 2 hours later. McKenna was working on a different P-38, his hands black with grease, coveralls stained with hydraulic fluid. Mitchell asked him directly what he'd done to Hayes's airplane. McKenna looked at him for a long moment, then told him everything. The piano wire tensioner, the cable modification, the unauthorized change to the flight control system. Mitchell listened without interrupting. When McKenna finished, Mitchell asked if he could do the same modification to his aircraft. McKenna said yes, but Mitchell had to understand the risks. The modification wasn't approved, wasn't tested. If something went wrong, both of them would face charges. Mitchell said he didn't care. He'd lost 4 pilots in his flight over the past month, all caught in turning fights they couldn't escape. If there was something that could help them survive, he wanted it. Regulations could wait. That evening, McKenna modified Mitchell's P-38 using the same method. Mitchell flew it the next morning and came back, raving about the improvement. The airplane rolled like a fighter instead of a truck, he told his wingman. The wingman immediately asked McKenna if he could get the modification too. By August 20th, McKenna had modified 9 aircraft. Word spread through the squadron quietly. Pilots started asking their crew chiefs if they'd heard about the cable modification. Some crew chiefs refused, saying it violated regulations. Others were willing to try. McKenna showed them how to do it. Cut the piano wire, bend it into a Z shape, install it as an inline tensioner. Takes 8 minutes, changes everything. The modifications spread from pilot to pilot, mechanic to mechanic. No official documentation, no engineering approval, just whispered conversations in ready rooms and maintenance areas. Hayes shot down 2 more Zeros on August 22nd, using the modified controls. Mitchell got 3 on August 25th. Other pilots started returning from missions with kills. The statistics became impossible to ignore. In Lieutenant James Watkins, a crew chief with the 49th Fighter Group stationed at Gusap, heard about the modification from a pilot who transferred from WWII. Watkins was skeptical but tried it on 1 aircraft. The pilot came back from the next mission with his first kill after 8 weeks of combat. Watkins modified 4 more aircraft. Other crew chiefs in the 49th started doing it too. By early September, maybe 40 P-38s in New Guinea had the modification. The engineering officer at WWII noticed something was different but couldn't figure out what. Control cable tensions checked out during inspections, because the crew chiefs would remove the tensioners before inspections and reinstall them afterward. The pilots knew, the mechanics knew, but nobody told the officers. The kill ratio started shifting dramatically. In July, American pilots in the Southwest Pacific lost 2 P-38s for every Zero destroyed. In August, it dropped to 1.3 to 1. By September, it was nearly even. Something had fundamentally changed, but officially, nobody knew what. Then the Japanese noticed. Fighter pilots from the 11th Air Fleet began reporting in late August that American P-38s were maneuvering more aggressively, rolling faster into turns, reversing direction more quickly. Tactics that had worked reliably for months were suddenly failing. Lieutenant Commander Saburo Sakai was one of Japan's top aces with 64 confirmed kills. He'd been fighting American pilots since Pearl Harbor. On September 3rd, Sakai engaged a P-38 over Wewak using his standard tactic: draw the American into a turning fight, wait for the P-38 to begin its roll, then snap his turn back the opposite direction to get inside the American's turning radius. Except the P-38 reversed with him. Sakai had executed this maneuver dozens of times. He knew exactly how long it took a P-38 to roll. He knew the timing perfectly. But this P-38 rolled faster than it should have. Sakai barely avoided a head-on collision. The American got guns on him and Sakai had to dive away. He returned to base confused and frustrated. Other experienced Japanese pilots reported similar encounters. The Americans weren't flying differently or using new tactics, but their aircraft were responding faster, fractionally but enough to matter, enough to disrupt the timing that Japanese pilots had learned to exploit. Japanese intelligence tried to determine what had changed. They examined wreckage from downed P-38s but found no obvious modifications. The aircraft looked identical to the ones they'd been fighting for months. Engines were the same, armament was the same, nothing visible had changed. What the Japanese didn't know was that the change was hidden inside the boom, a 6-inch piece of piano wire that looked like original equipment. Even if they'd found it, they might not have understood its purpose. It wasn't a new weapon system or a new engine, just a minor modification to control cable tension. But that minor modification was killing their pilots. By mid-September, Japanese pilots were losing aircraft to P-38s at rates they hadn't seen since early in the war. The psychological impact was significant. For 2 years, Zero pilots had owned the sky in turning fights. They knew they could outmaneuver anything the Americans flew. That confidence was breaking down. Pilots who used to press attacks were becoming cautious, hesitant. They weren't sure anymore if their tactics would work. The Japanese tried to adapt. Some pilots stopped trying to get into turning fights with P-38s and used hit-and-run tactics instead, but that meant giving up their main advantage. The Zero's strength was maneuverability. Fighting like a P-38 meant fighting on American terms, and the P-38 was faster, more heavily armed, and could take more damage. Other pilots tried to compensate by being more aggressive, closing to shorter range before firing, taking more risks, but aggression without the ability to outturn the enemy just meant dying faster. Several experienced Japanese pilots were killed in September trying tactics that had worked perfectly in July. The fundamental problem was that they were fighting an enemy they couldn't see. They knew something had changed but didn't know what, and couldn't figure out how to counter it. You can't develop tactics against a modification you don't know exists. By the end of September, the 11th Air Fleet had lost 38 fighters in combat with P-38s. American losses in the same period were 22 aircraft. The ratio had reversed. For the first time in the Pacific War, P-38s were killing Zeros at better than a 1-to-1 rate. Japanese command ordered pilots to avoid engaging P-38s unless they had significant numerical advantage. That order marked a turning point. The Zero had gone from hunter to hunted, all because of a piece of piano wire that nobody was supposed to install. The modification never became official during the war. The Army Air Force Engineering Command learned about it in October 1943, when a maintenance inspector at WWII noticed inconsistent cable tension readings. He traced the discrepancies to the piano wire tensioners, wrote a report, and sent it up the chain of command. The report sat on desks for 3 weeks while officers debated what to do. The modification violated regulations, but it was working. Fighter squadrons using it had measurably better kill ratios. Pilots were surviving. The question wasn't whether the modification helped. The question was whether to punish the mechanics who'd installed it without authorization, or quietly approve it after the fact. In November, Lockheed sent an engineering team to New Guinea to evaluate the modification. They tested it, measured the cable tension, calculated the stress loads, ran flight tests. Their conclusion was that the modification was safe and effective. It should have been part of the original design. Lockheed integrated a similar tensioning system into the P-38J model that entered production in December 1943. But McKenna never received official credit. No commendation, no medal, no mention in any report. The official Lockheed documentation attributed the control system improvement to engineering analysis. McKenna's name didn't appear anywhere. Hayes survived the war. He flew 63 combat missions, shot down 11 Japanese aircraft, and returned to Iowa in 1945. He married his high school sweetheart, had 4 children, and worked as a crop duster for 37 years. He never forgot what McKenna had done. Every year on August 17th, Hayes called McKenna to thank him for saving his life. Mitchell also survived. He became a squadron commander, led his unit through the Philippines campaign, and shot down 16 aircraft. After the war, he stayed in the Air Force and retired as a colonel in 1963. He told the story of McKenna's modification to every young maintenance officer he supervised, making sure they understood that sometimes the best solutions come from enlisted mechanics who see problems the engineers miss. McKenna stayed in the Army Air Force until 1946, then returned to California and went back to working on cars. He opened his own garage in Long Beach in 1948 and worked on engines for 42 years. He never talked much about the war. When people asked, he'd say he was a mechanic who fixed airplanes, that's all. In 1991, a military historian researching P-38 modifications found references to the piano wire tensioner in maintenance logs from New Guinea. The historian tracked down McKenna through veteran registries. McKenna was 73 years old by then, still working part-time in his garage. The historian asked him about the modification. McKenna confirmed the story but said it wasn't anything special, just something that needed doing. The historian estimated that the modification may have saved between 80 and 100 American pilots' lives based on survival rate improvements in squadrons that used it. McKenna said he never counted. He just remembered the pilots who came back. Hayes, Mitchell, Watkins, and the others. That was enough. James McKenna died in 2006 at age 88. He was buried in Pacific View Memorial Park in California. His obituary mentioned his service in World War II as an aircraft mechanic. It did not mention the piano wire tensioner, did not mention that he'd changed how American fighters flew, did not mention that he'd broken regulations to save lives. His garage in Long Beach is still there under different ownership now. But on the wall in the back office, there's a faded photograph showing a young mechanic in coveralls standing next to a P-38 Lightning. The date written on the back is August 1943, New Guinea. That's how innovation actually happens in war, not through official channels or engineering committees, but through sergeants and mechanics who see problems, find solutions, and don't wait for permission to save lives. This story matters because it reminds us that heroism comes in many forms. Sometimes the people who change history aren't the ones flying the planes or leading the charges. Sometimes they're the ones working alone in the darkness with a pair of pliers and a piece of wire, doing what needs to be done, regardless of the consequences. McKenna knew the risks. He knew he could face court-martial, imprisonment, or worse, but he also knew that pilots were dying because of a problem he could fix. So he fixed it. That kind of courage deserves to be remembered.